Hello and most welcome to 1211. Finally some firm ground to stand on. Seems brilliant. High above everything else. And we continue with the contra request of Chris Fields and Chetan Prakash. Postulating an architecture is by its very nature going beyond lived experience to the realm of theoretical models. We fully agree with Kordash that pretending to eyes of God that see all agents, their actions and interactions, is a mistake. But we nonetheless regard an ability to build, consider and derive predictions from theoretical models as an essential adjunct to phenomenology. The formalism and diagrams of von Förster, for example, compose such a model, as do those of Carl Friston or Wojciech Zurek, or indeed of any other author who claims to explain or predict an experience of any observer. Kordash is no exception. By renouncing the view from nowhere, consciousness appears everywhere, may well be a report of first-hand experience, but saying how this happens requires a model. For many, moreover, consciousness appears everywhere only from a theoretical view from nowhere perspective, one from which the futility of attempts to make consciousness emerge from something else becomes evident. Consciousness appears everywhere in the CA framework via a postulate. Conscious realism. This postulate is not as radical as it seems. Two CAs defined to have the same world, set W, can be taken to represent 2 points of view on the world. If, however, the world is reconceptualized as simply the information channel via which the agents interact, its degrees of freedom can be subsumed into the perception and action maps of the agents to produce the interacting agent configuration shown in Figure 1C, our target article. Of our target article. From the perspective of either agent, the world is indistinguishable from the other agent. René Descartes realized this in his meditations, stating that nothing in his experience could prove that he was not interacting with an evil demon that synthesizes every percept. The currently fashionable idea that we, each, live in a computer simulation constructed by some advanced race, maybe even our own descendants, updates Descartes. The simulation is, in this view, the channel by which the aliens, or maybe our grandchildren, toy with us. The interface is a boundary in state space, not space-time. Kaufmann and Konrad Werner both wonder how the interface is defined, a question that is present but implicit for both Dietrich and Kordisch. Kaufmann asks, in particular, whether we require the interface to be a physical surface, later attributing to us the notion that the fundamental source of the epistemic boundary is space-time itself. The word physical here is ambiguous. Physicists often use it to mean merely consistently describable in the language of physics. Ruling out as unphysical only situations with mathematical descriptions that are self-contradictory or meaningless. We can, however, state categorically that we do not require the interface to be a boundary in space-time, and we apologize if anything in our text suggesting this. We regard space-time as a way of encoding information on an interface, one that may or may not be used, but that provides the benefit of some level of error correction. Human experience, and thus the typical human interface, employs space-time to advantage for encoding percepts, some concepts, for instance those of geometry, but other kinds of observers may have interfaces that do not employ space-time, or that employ space-times with more or fewer dimensions, or even different geometries from ours. Encodings of some kinds of human experience, of emotions or epistemic feelings, tend to employ time but not space. Nothing requires or even suggests a common encoding across the entire interface. The notions of open and closed boundaries of classical mereotopology are motivated by the characteristics of ordinary objects occupying continuous locally Euclidean spacetime. Hence, it's unsurprising that, as Werner shows, they are of little use in understanding the kind of interface proposed here. Werner rejects, in particular, characterizations of observer or perceiver and environment, outside world, as mereotopologically neither open nor closed. If either is open, its complement must be closed. Observing environment are, however, in this model entirely equivalent and interchangeable. This is why we draw them as symmetrically and prefer the neutral Alice and Bob nomenclature to the connotation-laden observer and environment. nothing motivates any structural distinction between the two. Hence, there is no justification for a mereotopological distinction. Given that they interact, we are left with a situation that Werner labels in Borders perception world. Both systems are closed and they share a boundary. While the boundary is shared, however, the system cannot be both closed. Observer and environment together compose the entire universe, which, as Barry Smith points out, is boundaryless and hence not mereotopologically closed. It is, however, closed to the physicist's sense of not interacting with anything. The situation is rendered even more paradoxical by noting that observer and environment each appears fully embedded in the other when viewed from its own perspective. Kaufmann remarks that the most generally applicable epistemic boundary is any distinction whatsoever. The distinctions between red and green or between happy and sad are examples. Any property that supports such a distinction, what physicists call a degree of freedom, can be thought of as a component of the state of a system. The boundaries in which we are interested are boundaries in the abstract state space. Of the universe. Observer and environment are distinguished as subsystems by the states that they can occupy. The epistemic boundary between them, the boundary by which we, as theorists, distinguish them, is their shared interface. The states on this boundary are available to encode experiences. They implement the respective spaces X of observer and environment in the CA formalism. What is encoded on the interface at any instant of either system relative time, depends on how the two systems are interacting at that time. The interaction need not involve spatial degrees of freedom, as Kaufmann made clear in his discussion of the entanglement. All boundaries encode experience, but all boundaries can be erased. Kaufmann remarks that any distinction whatsoever creates an epistemic boundary, is, however, even more powerful than this. It implies, when taken seriously, that every possible boundary in state space encodes experience. Every system is an observer. Likewise, every system is an observed environment. Every state corresponds to an experience on some interface. The universe is therefore filled with experiencer and filled with experience. In this sense, contra cordis, the abstract space in which agents live is indeed a space of phenomenal experience. Each agent, however, experiences only what is encoded on its own interface. Sensations, thoughts, feelings, imaginations, the experience of deciding or doing, all are encoded on the interface. All are eigenstates. Each agent's internal bulk states are experientially inaccessible to it, even though each of them is on the interface of, and hence encodes accessible experience for some agent. To see this in the simpler arena of space-time, think of the constant experiences of your own neurons, of which Cook 2008 provides a compelling description, all of which are inaccessible to you. Each agent's internal bulk states are experientially inaccessible to it, even though each of them is on the interface of, and hence encodes accessible experience for some agent. To see this in the simpler arena of space-time, think of the constant experiences of your own neurons, of which Cook 2008 provides a compelling description, all of which are inaccessible to you. Expanding one's theoretical perspective to the entire universe, considered as a whole, however, produces not Kaufmann's hope for abduction, but Dietrich's dialectic paradox, as described in paragraph 7 of our target article. Both classical and quantum physics allow their inter-system boundaries to be moved or erased arbitrarily, without affecting joint system dynamics. This constancy of whole system dynamics under arbitrary decomposition has been termed decompositional equivalence. Within the CA formalism, decompositional equivalence is implemented by the arbitrary composability of Markov processes. The universe as a whole has no outer boundary. Decompositional equivalence allows the erasing of any inner boundaries as well. Hence, the universe can be considered to be filled with observers and experiences as described above. But the boundaries defining these observers can also be erased with no effect. In the CA formalism, the universe can be considered to be a CA or any combination of CAs, but it can also be considered to be a single set. W mapped to itself. If any distinction creates a boundary, such a boundaryless system can make no distinctions. With no boundary to serve as an interface and no ability to make distinctions, the universe has no experience space X and no experiences. It has no point of view on itself or anything else. John Wheeler's well-known statement is therefore misleading. The universe is composed of observer participants, but is, when viewed as a boundaryless whole, itself neither an observer nor a participant. Taking actions into account deepens the above paradox. Boundaries encode not just experiences, but actions. The perception of each agent are the actions of its environment and vice versa. The actions of the agents drive the evolution of the universe. The dynamics of the universe, entirely composed of agents, is nothing beyond the combination of all their actions. Yet, from the theoretical perspective of the entire universe, none of these boundaries matters. Decompositional equivalence allows the erasing of all boundaries with no effect. From the perspective of the whole universe, there is no space-time, indeed no classical information, and nothing is happening. The universe is in a pure entangled state. That this fixed point exists is the physical content of the Wheeler-de Wit equation. The paradox posed by the universal view is, however, deeper still. The boundary erasure allowed by decompositional equivalence erases all interfaces and hence all encoded experience. From the theoretical perspective of the entire universe, consciousness and its contents are like decoherence, epiphenomenal. Decompositional equivalence renders a universe filled with awareness and a universe containing no awareness indistinguishable from a theoretical perspective that stands outside of it. The view from nowhere, even when adopted via an abstract model, is inherently paradoxical. Experience is both classical and non-classical. A partial resolution of this paradox of disappearing awareness may come from an unlikely corner. Marciano focuses on a particular system for which the state-space boundary corresponds to a spatial boundary, the black hole, and asks, Q1. how our approach might deal with the paradox that black holes appear to destroy information whenever they gain energy, in violation of quantum theory's requirement of unitarity and hence information conservation. As Marciano points out, one answer to this paradox is to recognize that black holes are only apparently classical objects. They are entangled with the rest of the universe by soft photons and possibly other quantum hair. As all systems smaller than the universe as a whole are observers in our approach, black holes are observers. Indeed, they are ideal observers. All information, particles or waves that contact their surfaces is both fully absorbed and holographically encoded. Black holes are also ideal actors. They constantly alter their states of the environments by emitting Hawking radiation. These observations and actions are classical. They can be observed by, that is, they can encode information on the surface interface of, an external observer. When the situation is viewed quantum mechanically, however, on the two sides of a black hole's boundary are simple quantum states, which to preserve unitarity must be entangled. The correlations that implement this entanglement cross the boundary. They are the soft quantum hairs. In Andrew Strominger's formalistes, these soft hairs are the decohering environment for the Hawking radiation. The latter is detectable by us only because the soft hairs are there. The soft hairs themselves, however, are not detectable. They carry zero energy and hence cannot encode classical bits on an interface. The interfaces of black holes, our ideal observers, are thus more complicated than is depicted in figure 3 of our target article. Not only do they encode classical information, they are also a locus of quantum correlation. The former cannot happen without the latter. If the encoded classical information is the content of recallable, reportable and classical experience, the kind of experience that can be remembered or put into a sentence, then it is natural to regard the boundary crossing non-classical correlations as a kind of ineffable non-classical experience that can be neither remembered nor reported. Without this ineffable experience, recallable, reportable experience could not occur. How interesting, it's so true. Without the ineffable experience, recallable, reportable experience could not occur. And this is a big problem for classical physics. It doesn't explain how recallable, reportable experience could occur. For them, everything is under the light. Everything is reportable, but that leads to a paradox. It leads to the paradox of the observer. Then the observer has to be everywhere, constantly, permanently watching everything. Well, it's the panopticon and the homunculus together. If all of the boundaries in the universe are erased, the classical reportable experience disappear. It is, as noted earlier, epiphenomenal from a whole universe perspective. The non-classical experience, however, remains. The quantum correlations that implement this non-classical experience constitute the universal entangled state, the fixed point of the universe's timeless evolution. Hence Kaufman's abduction can be partially recovered. The universe remains filled with the ineffable, non-classical experience even when all observer system boundaries have been removed. Perhaps Kaufman's places of ambiguity point to this non-classical experience, as surely do Dietrich's dialetheia. William James's fringe of consciousness similarly seems to point here. What is it like is not one question but two. Kordesh in paragraph 14 introduces the traditional distinction between what consciousness does and what it is like, suggesting that we may address the former, but we can say nothing about the latter. We disagree, for we claim that what is it like is two distinct questions. One asks, what sort of experiences might we expect a system to have? While the other asks what each of those experiences is like for each system that has it. The first of these questions can be answered, maybe not in all cases, but in some. We can expect bacteria, for example, to experience saltiness, and expect humans to experience time-persistent objects located in 3D space. We can expect both to experience the difference between well-being and its absence. What these experiences are like for each individual experiencer, however, remains unanswerable. It remains unanswerable, we would argue, even from a first-person perspective. What is the experience of green like? Is it like green? Even elaborating, saying that green is more like cyan than red, contributes nothing to capturing, in a non-experiential terms, the experience of greenness. Remembering and then describing the greenness makes it, if anything, less immediate and vivid. Forcing experience into language, even first-person language, distances it. Holography provides a mechanism for rendering experience classical. Beyond that, answering the "what sort of experiences" question requires the investigation and modeling of the particular interfaces of particular kinds of systems, that is, particular kinds of organisms, or even particular individuals. It requires us to take Werner's questions about the structure of sensory and cognitive systems seriously. Such questions inevitably lead to the field station, the laboratory or the clinic. It is once again a fair challenge to ask how and even such investigations can be fully and adequately described within a purely constructivist framework. We doubt it. Framed in Marciano's terms, what sorts of experiences becomes a mathematical question about the formal structures of model interfaces. Given an observer-environment pair, for example, what group structures characterize their interface? We have addressed this question from the reverse direction, showing that an interface with a given group structure imposes that structure on the experience world. For a finite interface, and hence a finite of classical experience, space X, such groups are finite, and hence they can be at best approximate continuous groups transformations, those of the Lorentz group, that is. Whether the CA formalism can replicate the graph structures employed by physicists while maintaining its intended interpretation is a topic of ongoing investigation. Kaufman raises a general question about encoded experiences. What does it mean to say that informational redundancy enabled by space-time or any other group structures corrects errors? As Kaufman notes, an experience per se simply is what it is. There is no sense in calling it an error. The errors that are corrected, in our view, are errors of association between experiences and action. Depth perception, for example, enables accurate grasping. Disrupting depth perception introduces errors. In some cases, experience-action associations are mediated by intervening experiences. An accurate representation of the time between a current sensory experience and a remembered experience, as encoded within the experience of recall happening now, may be required to choose an appropriate action, that is, whether to hurry to avoid to be late. It is errors of this sort that can decrease fitness and in extreme cases send fitness to a zero, stopping further input. For an organism, no action is repeated ad infinitum, and no eigenform is stable forever. In a universe where you cannot always get what you want, you are better off having an interface that gets you what you need. And that is the end of the rebuttal from Chris Fields, Donald Hoffman, Chetan Prakash and Robert Pretner. A fantastic answer, I would say, to the commentaries. And the world is not surely classical, it's classical and non-classical. Everyday experience is that. Otherwise we couldn't have any observations at all. And for me this is fantastic. This is a way of showing quantum mechanics is already existent in our world. We know that people who use quantum mechanical thinking to a greater extent usually are much more successful, whereas those lingering on to the classical model never manage to make decisions that are effective. This is from Heidegger and other researchers in prediction results and cognitive science predictions. So we know that. And one of the rebuttals were actually just that the world was completely classical and the quantum mechanical world was a world of theory. No, says Chris Fields, not at all like that. Actually, the classical world also contains paradoxes, and they are unresolvable, and they would remain to be that if it weren't for quantum mechanics. Now all of a sudden we have two worlds. We have the reportable world or the reported world, but it's always coming from an unreportable world, the quantum world, so to speak, the superposition. And once more we see here the duality between potentiality and actuality. This is what makes up the world. Without priming your head, without having the creativity to think something different from what has been perceived before, there can be no thinking whatsoever. This is typically of all subjects Heidegger takes up. They are all locked in the classical model, and those are people whose life do not function very well, but also whose bodily motions do not function. They are slouched, couched, collapsed in their bodily posture. Their thinking is likewise collapsed, non-functioning, and when it's not functioning, everything is based sheerly on actualities. Potentialities disappears, and these people seem to think the whole world is made up of things that are reportable. And you see what this maelstrom, this vicious maelstrom can take you. It's a current that takes you down into subjectivity. Because who is doing the reporting? It's you. And for every time you do the reporting and you think it is shared by anyone else, you will sort of put yourself deeper into that level of non-understanding. Because without something that is non-reportable, there cannot be anything reportable as well. And this is odd. The most exact reports are also made by these successful people. Steve Jobs is one of those. So they excel both in the classical mode because they have access to so much more potentiality of unreportable things. So when they make their report, it can be so much more exact. And that was the point coming from Kaufman. Without the openness or the potentiality, the borders are doomed to become shallow, non-distinct, obtuse, dimmed. We get this unreal, obfuscated, as we say in Swedish, it's not chopped and it's not milled, grinded, varken hackat eller malet. Now we come into the modern experience of living in the world, being in das Man, and thinking that you share your experience with others. No, only the combination of potentiality and actuality can open the doors to sharedness with other people, because potentiality is the resource or the energy field that makes it possible for you to enter into a communal shared realm. Otherwise, you are going into the direction of private language. And so, aptly put, I think it was a Boström, private language is not an option. It is when you are in the maelstrom, where you, for every time you report, you ask another question. What is it? How is it? You drag yourself down into the deep pit, and you end up in the cave of Plato. And I would say maybe it is from that cave there is little or any return. The potentiality, the borderless quantum mechanics is what makes borders possible. So you see, even though they are completely opposite, and this is what Kirchner say with dialephism. Dialephism, for those who are forgotten that, is the paraconsistent logic of Graham Priest. And this is also criticized by Chris Fields. We don't need to have contradictions in the world. Not like that. Incommensurable contradictions. Our foundation is in itself contradictory, but that is what makes the world possible. If the whole world was classical, in contrast to what Drescher says, there wouldn't be a world at all. And this is what quantum mechanics is showing. It's showing also the foundation for the classical world. And without this energy-laden, filled with potentiality of the superposition, nothing would come about. And I think I'm anxious to answer the phone here. Well, anyway, I'm finished there. It was excellent written things. I say thank you very much and have a very pleasant afternoon. Bye bye.